Hello everybody, and welcome to our next webinar on XR workflows using Unreal Engine. My name's Daryl Aubert, and today I have the pleasure of presenting with my good friend Victor. We're going to be looking at two XR projects that are based on the templates that ship with Unreal Engine. The first project's going to be a desktop VR experience created by Victor. The second project will be an AR experience running on mobile devices. We're going to cover what the templates are capable of doing out of the box. Additionally, we'll show a few examples of how to add custom functionality to further extend their capabilities. So with that said, we've got a lot to talk about, so let's get right into it, and I'm going to pass it over to Victor.
Hi everyone, my name is Victor Broden, and I'm a product specialist here at Epic Games. You might have seen me host our weekly livestream Inside Unreal, but I'm now part of a dedicated team focused on making OpenXR a first-class citizen in Unreal Engine. OpenXR is an open standard for virtual and augmented reality platforms and devices. In 4.27, the plugin became production ready, and we updated the VR template to take advantage of it. It now supports a majority of VR devices out of the box and contains the following features: movement in the form of teleportation and snap turning, a component-based grab system, a framework for passing input to held objects, a hand menu that has one-handed and laser pointer style input, a VR spectator blueprint that enables a third-person perspective, great for screenshots or videos such as this one, and a spatialized audio example powered by the Google Resonance plugin. The template is designed to be a starting point for your VR projects, and it's easy to modify and extend. You'll find the OpenXR VR template by launching 4.27 or later versions of the Unreal Editor. Choose the new project category Games, and select the virtual reality template from the list. Name it appropriately, and create project. We've started out by migrating a custom scene into the VR template project. To make the scene work for VR, we have to do two things. First, add a player start capsule and align it so that the center is aligned with your floor. Or find the VR pawn, place it in your scene, and set auto possess player to player 0. Next, we want to add a nav mesh bounce volume scale it to fit your navigable bounds, by default, the visualization for the navigation mesh is not enabled, but you can use keyboard key P to toggle it on and off. To adjust the navigation mesh generation, find the recast nav mesh default actor in the scene, go down to the generation section, and play around with the settings. I like to adjust agent radius. Sometimes you don't want certain objects in the scene to affect the navigation mesh. You can select them, search for nav in the details panel, and uncheck can ever affect navigation. Depending on how your models were imported, they may or may not have collision. For teleportation to work, your floor meshes has to have collision and be set to world static. This floor clearly doesn't have collision, or it has the wrong collision setting. Let's go ahead and see what's going on. In the static mesh editor, we can go ahead and click the drop down for collision, and we want to show simple collision. Now, we can see that there's actually nothing else being shown here. This means that this mesh does not have collision. If we head up to the collision tab, we can simply generate a box simplified collision for this mesh. For floors, this works well. Let's go ahead and save that, and voila. Gaps like these are usually not a problem, but in this particular instance, we can go ahead and solve it by once again selecting the recast nav mesh actor and setting our cell height to something a little bit higher. Unless you want players to be able to teleport up onto the table, you can use the nav modifier volume to determine areas where the player are not allowed to move. you might have noticed that the plain VR button is grayed out. There are several runtimes that support OpenXR, such as Oculus, SteamVR, Monado, and Varjo. But the runtime might not support your device. When in doubt, use the native runtime for your device and make sure that the OpenXR runtime environment variable is set to it. Most runtimes now implement a setting to change it, but you can also use OpenXR Explorer, which is available on GitHub for free. With our runtime running and our OpenXR environment variable set to it, VR Preview becomes available. But before we don the HMD, let's go ahead and change our Play in Editor viewport to be displayed in full screen. Click the arrow next to the play button and select Advanced Settings. You might be able to find your monitor underneath the Common Resolution settings. However, I know that my monitor is 1920 by 1080. And now we can finally play in VR. The VR template comes pre-configured with actors that can be grabbed. Let's go ahead and create our own. Blueprint class, actor, let's name this BP remote. Let's go ahead and add a static mesh component. We'll name that remote as well. And then let's replace the default scene root with our static mesh component so that this is now the root of this actor. Next, we're going to need a grab component. This is a custom component that is not part of the editor by default. However, since we created this project from the VR template, we have access to this component. Now, let's go ahead and pick a static mesh for our remote. I know there's a Google Data Room controller that kind of looks like a remote, so that's what I'm going to pick. The grab component gives us a couple of options in regards to how this grab will function. Free grab allows us to grab this object relative to where the hand is when we grab it. Snap is perfect for something like a pistol or a remote in this case, so that's what we're going to pick. The location of where this grab will occur is determined by the grab component itself. So a simple way to visualize what this would look like is to add another static mesh. We'll set this to be the Oculus V2 controller, since that equals the Oculus Rift S. And now we can go ahead and align the grab component Since this static mesh is only for reference purposes, we'll go ahead and set it to hidden in game, and we'll go ahead and disable collision. Next, let's go ahead and simulate physics on the remote so that it falls when we drop it. Let's go ahead and compile and save that. We'll drag it out into the scene, put it on our little table here, and key to align it to the table. We'll just clean that up a little bit, and then let's go ahead and check it out. All right, got our little remote. Bye. If you take your virtual remote and bake it in the oven for an hour, you might end up with a version that has the power to change actors in your scene. By using the grab component, input framework, and some custom blueprints, it doesn't take long to put together something like this. We're not going to build it step by step, but let's take a look at the concepts. At its core, the system consists of two actors: BP Variant Remote, which handles most of the logic, and BP Variant Actor, which contains the different variants. We have three children of BP Variant Actor right here. The remote tells the variant actor to cycle through actors in the variants array. The logic is also set up in the construction script, which makes it possible to switch between them in the editor viewport as well. Let's take a look at the remote. The grab component calls event dispatchers when grabbed and dropped. We're using those events to enable and disable tick. When tick is enabled, we line trace for any visible actors and visualize it by repurposing the Niagara system that's used for the teleport trace. It is then up to the state machine to manage setting a reference to our target variant actor, toggle the highlight effect on, and change the color of the Niagara system. By adding the Blueprint Interface VR Interaction BPI, this actor will now receive input from the motion controller that's holding it. If the trigger was pressed while we're aiming at a variant actor, cycle it and make sure that the new actor is highlighted. If you want to try out the variant remote yourself, download the asset from the link below and add them to the VR template. And for our last example, let's go ahead and add a new option to the hand menu. You'll find the menu in the Blueprints folder. There's the menu actor that handles a lot of the logic, and then the widget. To add a new option, select one of the buttons and the text component, copy, select the vertical box that contains our buttons, and paste it. Let's change the name. And for this component as well. And we'll change the text to just say something simple like spawn. Then let's head over to the graph, select our spawn button, and add an on-clicked event. And after about 30 seconds behind the scenes, we made ourselves a menu button that spawns cubes. Perhaps not the most useful, but something had to happen when we click our new button. Remember, the menu can be useful for both in-game options as well as debugging. That's all for today, but if you're interested in learning more about the VR template, check out the livestream I did with Alexander Pascal. You'll find the link below. And head over to the XR development category on the forums if you have any questions. Thanks for watching.
Wow, that is super cool stuff, Victor. Thank you so much for that. So we're going to be jumping into the AR template projects, and there's a couple places you can find them. The AR template lives inside of the automotive product design. It also exists inside of architecture, engineering, and construction, and in games. We're going to grab the AR handheld template out of the games folder and just create a new project to walk you through the basics. When you first open the AR project, you're not presented with very much, but there are some online prompts to launch the docs to get the Android development environment installed. Make sure to install Android Studio 4.0. After you agree to the terms and set Android Studio up for first-time use, you then need to set up the Android NDK. This is done by running a bat file that can be found in the program files, engine version, extras, Android. After running that bat file, your computer is now set up with the environment it needs to run Android and do development. The next step is to get your Android device in developer mode. This is important so that you can communicate with the computer. This is done by going to the About section for the Android device, clicking on the version number of the operating system 7 times, and then unlocking the USB debugging tools. And this is very important. After that, you're ready to plug your device back into the computer and begin working with the project template. So here we are back in the AR template project with all the Android development software properly installed, and I've gone ahead and plugged my tablet into the PC. Now, before we can push this project onto the mobile device, we need to configure a few project-specific settings. So this is easily done by going to Settings, going to the Project Settings drop-down, and scrolling down to Platform. Inside of Platform, we want to select Android, and you can see that we need to configure this project to work with the Android platform. Really straightforward, just click the Configure Now button. It goes from red to green. That means we're good to go. So the next thing that you want to do is make sure that you accept the SDK license. I've already done that, so mine's grayed out, but yours most likely won't be. The final step in the project settings is to give your project package a name. So instead of being your company with this project token, I'm just going to make this say Epic Games with the name of my project. So with that done, you can see that it's AR Webinar, which matches my project name. We can close this down. So before I deploy this to my tablet, I want to just give you a quick overview of a few things that are happening in this default project. Because right off the bat, it doesn't look like much, right? Like there's a couple lights and then all the help things that we clicked on previously. So the way the lighting model works is there's a directional light and there's a skylight. The skylight has a cube map that's defined. It's just this kind of default ambient map that's going to be used for the reflections. If we jump into the handheld AR folder and go into the configuration file, you can see that the lighting mode is set to use an ambient light estimate. So this means that the device is going to sample the environment and use that sampled information to drive the lights that are in our scene currently. So it's going to try to match the lighting model and kind of base it off of the environment that it's in, which is pretty awesome and pretty straightforward. Now, all of the logic for this project is actually built using Blueprint, which is great because that means it's highly extendable and you can use it as a learning tool. You can rip it apart and see what's going on. And we're going to be doing a bit of that more in depth later on in the presentation. But I do want to just kind of pull up a few things and just kind of walk you through a couple areas that might be interesting to look at. So if you go into the blueprints and you go into the game framework and you pull up the BPAR pawn, this is where a lot of the logic's happening. So you can see if we kind of just scroll over here, it's using some of the information to figure out what type of gesture you're doing, because that gestures are going to drive whether you're a scale, move, or rotating the object. It's got some logic in here for fetching the camera depth. So there's just lots of interesting things kind of happening here. If I kind of zoom out, you can see that, you can use this to try to understand and dissect what's been going on in this project, which is pretty straightforward. So all the logic's kind of built up using blueprints, I guess is the point that I'm trying to make. Additionally, all the user interface elements are also built up using blueprints in UMG. So if you go into the UI folder, you can see, like, if we grab something like the start menu, obviously this is built using UMG for the text and the buttons and things like that. And if you jump over into the graph, you can see that there's some blueprint code that's taking those to then execute off and do some certain things in the project. So again, it's extremely flexible for an artist to come in here and start to rip this apart and build their own custom logic or custom projects, specific settings that they might want to use. So that's pretty much it. Now the next thing that I want to talk about is, right now you don't see any objects in the scene, and that's because the objects kind of get placed when you click on a plane in a certain spot after you've scanned the environment. So how do you add your own custom geometry into it? Well, if you go back into the handheld AR folder and go into blueprints, the one that you want to get into is in this placeable folder. So in placeable, there is this BB placeable actor. This is really where a lot of the magic is happening. So if you double click on this guy and we jump over to the viewport and kind of zoom in on this, and you look at this guy, you can see that that's that kind of default little character. So if you want to add your own custom mesh in here, the easiest way to do it is to highlight underneath your, underneath this little hierarchy here, the BP production asset ref. That's going to allow you to change what static mesh is being used or being placed in the AR experience. So we can just click on this guy and I'll just search out for like another static mesh. We'll grab that color calibrator, kind of zoom back on that guy. Now the scale on this is a little bit different, which is very similar to something that you might be bringing in. So I'm just going to rise that up. And once you get that kind of positioned at the bottom of the ground plane there, you're going to want to go back into that BP production asset ref, and you're going to want to adjust the plate scale. So this is going to adjust the overall UI placement element as well as that kind of grounding shadow. So you're going to want to make that sort of float underneath that object in a sort of nice way, kind of like that. Now let's just undo this and get back to those original kind of generic pieces of geometry that shipped with the project. And we'll use this to go ahead and generate our first AR experience. And I'll give you a quick demo of what it's like on the actual Android device. So what we're going to do is we're going to add this to the Android device very simply by going to the launch dropdown, clicking on this and selecting my Android device. Now, if your Android device is not showing up underneath this list, most likely what's happened is that USB debugging hasn't been enabled, or you didn't hit yes in a spot that you needed to say, yes, open up the permissions, allow this USB debugging. That's most likely where it's going to, where it's going to fail if for some reason it's not showing up there. Now, obviously mine's configured correctly. So I'm just going to click on this guy and we'll start adding this onto my Android device. So as that goes, I'll just click on the output and you can see it's just rolling through here, giving me back all the information as it goes and builds the executable, and then it'll start to deploy it onto the Android device. And there might be a few pop-ups that happen on the Android device, when you're pushing things onto it that you need to agree to, to continue the application being added. Things like opening up the camera. The first time you run the app, it's going to ask, do I have permission to run the camera? So you basically are going to say yes to pretty much everything that shows up on that. So just keep an eye out on those prompts that the actual tablet or phone might be throwing up at you as you start to work with the application. All right, great. So it's now running on my Android device, and we have successfully deployed this application onto the Android. So just like that, it's done. Pretty straightforward. When you first launch the AR template project on a device, you need to scan the environment. By scanning the environment, you're defining the plane that you're going to place your static mesh actor on. After you've scanned the environment, you click and tap where you want to place your static mesh. With the static mesh placed, I'm going to bring up the Help menu. You can use gestures to move, scale, and rotate the object. In addition to the placement and gesture movement of the object, the AR template has a variety of different UI looks that could further be modified with the blueprints and has the ability to take snapshots. So it's a pretty full functioning AR experience that you can then further extend. The next example is a bit more sophisticated, but it's still based on the same AR template. Obviously, we have some animated characters now in our experience, and we're using Control Rig to generate the shadows that you see underneath the feet as well as the hips. Additionally, we've now switched over to an iOS application, and we're using ARKit's ability to create refined reflection captures. So the reflection capture is continually being refined as I scan the environment, and it's generating a more complete reflection model that updates as we move through the scene. So it's really cool, and we're going to tap into that with a little bit of blueprint code. So let's go ahead and jump into the editor, and I'll show you how this is all done. Here we are in the editor, and the first thing that we're going to be working on is using Control Rig to generate those contact shadows that tracked the feet as well as the character's hips. So I've already imported into the project a bunch of geometry, so the basketball hoops as well as the animated robot. So he comes in as a skeleton mesh with some motion capture data. So if we double click on the robot and jump over to animation, you can see that we've got, we've kind of have this offensive clip here. And then, of course, we've got Robot B's clip, which is sort of the defensive clip. So what we're going to do is we're going to add in the functionality using Control Rig to track the position of the feet as well as the hips. Now, if you look at the hierarchy of this character, when it was set up in the DCC, we weren't really thinking about an AR app. This guy was actually used for the Cinema 4D motion graphics webinar that we did previously. So there's no helper bones inside of here already defined for Control Rig to drag around to ultimately drive some polygons that are going to be those contact shadows. So we need to extend this hierarchy a bit, and this is easily done inside of Unreal with virtual bones. So I'm going to right-click on top of the root, and I'm going to say Add Virtual Bone, and I'm going to add in a root-to-root bone. So as soon as we do that, you can see we have virtual bone, root-to-root, and it's basically added it in kind of right down here. Next thing that we want to do is we want to add in another virtual bone, actually two more virtual bones for each feet. So if we search for toe here, we're going to grab this left toe one. We're going to say add virtual bone. And again, I'll just search out for toe. So we're going to go left toe one to left toe one. We'll add that in. And then we're going to do the same thing for the right toe. So we'll say add virtual bone. We'll search for toe and we'll say right toe one, right toe one. So with all that done, we've now got these extra bones added in that ultimately we can use with Control Rig to drive the position of some polygons that are going to be the shadows. Pretty straightforward. So we'll go ahead and we'll save this out and we'll move on to the next step, which is creating the Control Rig. All right, so let's jump back to our content browser and just right-click on top of Robot and create that Control Rig. So if we double click on this, you can see here is a pretty similar hierarchy. And what we want to do is we want to use the forward solver to find the position of something and then use it to set the position of those virtual bones. And this is really easily done. So if we scroll down here and we grab this root virtual bone and pull it out, we're going to set its transform. So ultimately we want to have that virtual bone get driven by the character's hips. So we'll drag out the hips and we'll say, get a transform. Now, we don't want this transform to be a one-to-one match. We only want to match it in the Y and the X axis and ignore the Z axis. So we're going to expand out transform and translate, and we'll do the same thing on the set side of that bone. So we'll just expand those out, and we'll just wire up X and Y and just simply ignore the Z. So that's going to move it around essentially on the ground plane, but ignore the up and down movement of the character's hips. Pretty straightforward. So the next thing we want to do is something similar for the rotation. So we only want to get the Z rotation to match the kind of orientation of the foot or the hips as the character moves around. So we're going to go to rotation, and I'm going to pull out of that, and I'm going to just type rotator, and I'm going to say to rotator. And again, we're going to expand this out so that we can grab just that Z axis. And I'm going to pull this off, and I'm going to type rotator again, and you can see that there's a set rotator. That's not actually what I want. I want a from rotator, and it's not showing up. So if I turn off context sensitive, you can now see I have from rotator. So we can just pull that out, again, expand this guy, and just grab the Z axis off of that guy and shove that into rotation. So that is the setup for this guy. So we'll go ahead and compile on that. So the next thing that we want to do is basically the exact same thing for the other two virtual bones that we made. So I'm going to highlight all of these nodes and just duplicate them. We'll kind of move it over here, and we'll jump in here, and we'll just say, instead of hips, we're going to search for toe, and we're going to grab our left toe 1, and then we're going to do the same thing over here. We're going to search for toe, and we're going to add our virtual bone left toe. Pretty straightforward, and we'll just wire that execution up. And with that done, we can highlight this, Control W it, kind of move it over here, and again, search for toe. We're going to use the right toe 1 on that guy and have that match our virtual bone or drive our virtual bone's position for the right toe. Pretty straightforward there. And all we have to do is wire those guys up. So it's going through and it's taking those 3 virtual bones and setting their position with some limited axes, which is pretty straightforward. So we can compile that and save it. So we're done with the control rig setup now. So we've got that all figured out. So the next thing that we want to do is we need to get that control rig updating in the runtime, kind of, the animation of the character with the motion capture happening, and then the control rig, those bones positioning properly. And to do that, we're going to use an animation blueprint. And animation blueprints they're like a special blueprint. They allow you to work at a very high level with skeletal animations, data, and logic. So that's basically what we're going to do. So we'll just right click on top of this and we'll say animation, and we'll create an animation blueprint. And for the animation blueprint, we're going to grab this robot skeleton, and we'll just say, okay, on that guy. So with that done, we're going to give this a name. So we'll just call this ABP for animation blueprint, and we'll call it robot A. All right, so if we double click on this guy and bring it up here, you can see there's our robot. So what we want to do is we want to get that control rig. So if I just search out for control rig, we can get the control rig inside of there. And on that control rig, we're going to go ahead and set it to be our robot control rig. So that does that. And then we're going to obviously wire these guys up. And then we're going to come off of this source, and we're just going to get a play. And what clip we want to play is Robot A. So with that done, if we hit compile, you can see it's now flowing through, and you can see that virtual bone tracking the hips. And notice when the character jumps up that the little feet virtual bone stays stuck on the ground. So you can see that little trace line going up from the ground to the foot. So those virtual bones now are going to be our anchor points for some polygon planes that just have a transparent mask on them that create our ground plane shadows. So how do we do that? Well, it's with the help of one more simple blueprint. So we'll save this out, and we can close this guy down. Next thing that we're going to do is use a blueprint to attach some polygons to those virtual bones to create the shadows. And actually, before I do that, let me rename this guy. I gotta reverse those guys. So That's a little bit better. So to create a blueprint, right-click in the content browser and make a blueprint class. We're going to make an actor blueprint this time, and we're going to call this guy BP Robot, and it's going to be Robot A, actually. And then we're adding a shadow into him. So we'll just call it BP Robot A Shadow. So with that done, we'll double click on the blueprint to begin adding in some components. So what we want to do is we want to add the robot in. So we're going to go to the upper left-hand corner and click on Add Component and just search out for skeleton. We're going to add in a skeleton mesh. And then I'm going to jump over to the details panel. And right here underneath skeleton mesh, we're going to assign the robot skeleton mesh. So just like that, we've now got our robot in our blueprint. So the next thing we want to do is get the animation hooked up. Now in the animation section, it's already got an animation blueprint defined as the mode. So we just need to attach that last animation blueprint we did in the last step. So we're going to go animation blueprint robot A. And you can see now we've got a robot doing the offensive A version of the motion capture, which is pretty cool. So the next thing that we're going to do is add in a plane that's going to become our shadow maker. So let's go ahead and just click on Add Component one more time, and we'll search out for plane. And you can see that it added in a plane at the origin. Pretty straightforward. So we want that plane to attach to the virtual bone for the hips that is ultimately getting positioned by that control rig. So how do you do that? Well, you do that in the construction script. So we'll just jump over to the construction script and we'll pull off of that and we'll just search for attach. And we're going to do a component to component attach of the plane. And the next step is to define what's going to drive that plane or the parent. So we're going to grab the skeleton mesh and drag that into the construction script and just wire that into parent. So the skeleton mesh is here, but we haven't defined what part of that skeleton mesh do we want that plane to attach to? What socket name are we going to use? So we're just going to use that VB virtual bone root so that the hips shadow is getting made. So I'll go to this and just type out VB space root _ root. And if we save and compile that and jump over here to the viewport, you can see we've now got this plane that's tracking the character and rotating and doing what you want. Now, of course, you can kind of scale this guy down and start to dial in the overall effect that you might want. So we just want to get like a little kind of something, I don't know, 0.5 by 0.5 for the hips one. So it's kind of looking cool. And we'll add a new material. So we'll just search for shadow and we'll add the body shadow there. So you can see it starts to look pretty good. So we want to do the same thing for the feet. We have 2 more virtual bones that we want to have planes get positioned by. So I'm just going to grab that and do a Control W to add in 2 more virtual bones with that same material, or 2 more planes with that same material. And we're going to jump over to the construction script and we'll just grab this guy and we'll duplicate that, position it over here. We're going to grab plane 1 and have it become a target. We'll wire this up so that it kind of flows through. And we need to change the name of the socket so that plane 1 is getting positioned by that left foot. So I forgot what the name was. What was it? It was called left. Here, I'll just hit F2, Control C. We'll jump back over here and then we can just paste that in. And we're going to grab the skeleton mesh and the attached component. We'll duplicate that again with Control W. We'll grab out that third plane and just wire that in very quickly and hook that guy up. And we just need to, again, copy paste the name. So we'll just jump over here, hit F2, Control C, and then, kind of change that guy up right there. And with that done, we can hit save and compile and then jump into our viewport. And you can see that we've got 3 planes tracking those 3 virtual bones. So I'm going to grab these guys and just, I don't know, I think maybe 0.2 by 0.3 or something might look a little better on those guys. Cool. So there are our kind of little contact patches that we use to ground this character in AR, which is great. So we can compile this and save it. So the next step is to add this into the BP Placeable, similar to what we did in that first example. So we'll jump back to our Content browser, we're going to go up one level to the content folder and into handheld AR, into blueprints, placeable, and double click on BP placeable, this blueprint to bring it up. And you can see that I've already added in the basketball hoop and things like that. Pretty straightforward there. So what we want to do is we want to, underneath placeable, because this is going to get driven by the gestures in the hand and all the UI stuff, and it gets placed in the proper place. You know, anything underneath this node is going to basically go along for the ride. We want to add in another component. So what we want to add in is actually something called a child actor. So we're going to grab this child actor, and on that guy, we're going to come over here and we're going to tell it to be, it's BP, and it is Robot A Shadow. And, you know, this guy actually comes in really, really big. So that's a bit of an issue, but I'll just scale it down by 0.1, tab 0.1, tab 0.1, and just like that, we now have our little guy, you know, doing his thing, and we can just sort of position him, you know, where we think he might be kind of cool looking in AR. So, you know, I think it kind of had him sort of somewhere like that. Now, of course, we have two actors in there. We're kind of running out of time, so I'm not going to go through the process of building up the second one, but it literally is just a matter of, you know, kind of coming over here to the content folder, and inside a robot, just duplicating these two blueprints and switching over the motion capture data clip, and then dropping it in just like we did. So really, really pretty straightforward and very, very easy. So that is how you can build a control rig to make some shadow contact patch shadows, and then add that into the BP placeable to make that AR experience that we saw at the very beginning. All right, last thing that we're going to talk about is how we can use ARKit to create an environment capture or an environment probe that is constantly being refined. So as you move your iPad around, it's scanning the environment, it's using machine learning, and it's creating a more refined reflection capture or reflection probe, and it's super, super cool. So how do you do it? It's actually pretty straightforward. So the first thing we're going to do is we're going to get rid of the skylight that came with the AR template that's using this default cube map for its reflection. We don't care about that. So we're going to delete that guy. The next thing we want to do is create a new AR specific skylight. So to do that, if you right click and say create a blueprint class and then search for AR sky, you can see there's a special type of skylight that's an AR skylight. And we'll just go ahead and we'll select that. So we'll call this BP underscore AR underscore sky. So this is our BP sky. We'll just call it BP underscore AR. That's fine. This is our special skylight. So we're going to add that into our level, and we'll just kind of zero that guy out. So this skylight is expecting a probe to feed into it from iOS, you know, from the device, from the AR device. So to create the updating, refining mechanism, it's just a little bit of blueprint code. It's pretty straightforward, and we're going to do that in the level blueprint. So I'm going to say level blueprint, open level blueprint, and the first thing we need to do is create a new function. I'm going to call this function timer D, and off of timer D, I'm just going to pull out and create we're going to do a get all AR geometries by class. The AR geometry that we want to get is actually the Apple ARKit environment capture probe. This is the really cool one. So with that done, we're going to go ahead and we're going to take this array and just get a copy of it. And we're going to take that copy, and we're going to use that to set the environment capture probe. So if you start to search out for set ENV, nothing really comes up. If you turn off context sensitive, you can see that there's set environment capture probe. So we're going to grab that, and the environment capture probe target is actually going to be the blueprint AR that we have sitting in our level. So we'll just drag that in to get a reference to it and just map that into there. So that's starting to come together. The next thing that we want to do is we want to use, I'm just going to put a branch in here on this so that if it's true, it executes, and if it's false, it's basically just going to then fall back to the default image. So we're going to pull this out and just type branch. And so this is kind of like an if. And if it's true, you know, go through and set that environment capture probe. And if it's false, we're going to use the default probe that happened in the very beginning. So to drive that condition, what we're going to do is we're just going to get a length. So if you start to search for length, make sure you turn context sensitive back on if you turned it off, because in general, it does a pretty good job of filtering out what you need. So we want to get that length, and then we're just going to do a greater than. So if it's got something higher than 0, that is going to be that's going to be our condition, and it's going to basically flow that guy through. So we've got one more thing to do, and that's to clear out the timer by its own name. So at the end, we just want to clear it out and start it over, right? So we'll just drag off of this, and we'll just do a clear timer by function name, and then the function name is actually it's timer D. It's the function we just made. So function name is timer D. So with that done, we can compile this and save it. The next thing we need to do is get this to update, over and over and over and over again. So we're going to go back to the event graph, and instead of doing this on tick, what I'm going to do is I'm going to just on begin play, I'm going to set it by a function by a name. So we're going to come out here and we're going to say set timer by function name. So we're going to tell it to run the function name timer D, and we're going to have it run that every second, and we're going to loop it. And we'll hit compile and save. And just like that, we've now built the logic to automatically refine the environment capture probe using ARKit, which is just ridiculously cool. All right, so here we have the robots in the final state, and as you can see, that ARKit environment capture is doing a great job of capturing what this scene would look like and really making those Chrome robots feel like they're part of the environment. Additionally, we've got the contact shadows happening that are being driven by that control rig, and it kind of just all starts to come together. Now, the last thing we're going to talk about is iOS deployment, and it's going to be really a quick overview because we're basically out of time. All right, so we are quickly running out of time, but I do want to give you a couple of pointers about iOS deployment. So if you're on a PC, you can do a lot of the setup, but you will need a Mac and you will need Xcode to compile this project. So just keep that in mind. You can either copy the project over to the Mac, or you can do some fancy stuff where you actually have the PC communicate with the Mac and compile some stuff on there and have it all managed through it. It's all outlined in the docs, and I'm not going to go through item by item because we just don't have time for that. That could be a whole webinar in itself. But if you click on the help and you bring up the docs, it's going to give you a pretty good overview. Actually, it's going to tell you everything you need to know about this. Now, there are a few things when it comes to provisioning that I just want to draw your attention to. So the first thing that you're going to need to do is you are going to need to set up your signing certificate. And this can be done either on the PC or on the Mac. If you're on a PC, you just navigate to the directory, the iOS directory that's in bens.ios, and run the iPhone packager. And with that run, it's going to ask you for what project do you want to run it on. So I'll just grab this AR webinar project, and then it's going to bring up this window where you can create your certificate and key pair. So just give it a name. I'm not going to do the real thing. So we'll just say Daryl at DD, and then you generate your key pair. You just save that to, wherever, save it somewhere that's important, and you'll say generate request certificate. So that's going to give you basically the information that Apple wants. So once you do that, you save that out, you're then going to jump over to the Apple website. So I've actually already got my version of the Apple developers website up. So you jump into the certificates section and you'd say create new certificate. You'd go through and browse and grab that file that you basically generated and saved out. So you can see that I've already got obviously a couple of developer certificates set up. So after you've done that, the next thing that you need to do, and again, this is all in the docs, much more verbose than what I'm going through because we're basically out of time, but you go through and you set up an identifier. This is essentially the project identifier. It's really important that this name matches what's in your project settings, and I'll show you specifically where that is. So after you make your project identifier, you'd go through and you'd add all the devices that you own, again, in the docs, and then you would save out a profile that you would then import into Unreal. So let me show you this identifier and where you would import in all the certificates that you basically get saved back out. So you generate some requests on your end, you go to Apple's website, you give them the information that you've generated. It will then spit back out more information and signed keys that you then add into your project. That's essentially what's happening here. So if we go back to our project settings, even though I'm on a PC, this will still show up. In project settings, if you go down to iOS, under platforms, you can see that the provisioning's happened. It's valid, as well as a certificate that came back from Apple. It's also valid. And this is where the bundle identifier needs to match the project identifier that you set up in the identifiers here. So you'll notice that this is exactly the same name. It's .com/Daryl.ar.1. So that's the identifier for this project. So like I said, it's in the docs. Hopefully you guys can follow along and it makes sense. That is essentially it. Thank you for taking the time to check this out. We saw a lot of really interesting things. Thanks, Victor, again, for the amazing work that you did on the VR template. Super, super cool. And I hope you guys like the AR stuff. We covered an awful lot pretty quickly.